because I was it means that I sent a message in last class for no reason. I mean, if I was taking the class, only you and Aran must be present in the class, because I don't think so anyone else attempted those questions. Anyways, so because today I thought to discuss so many things, so we will surely be doing it. Number one, see, if we look at atomic structure, we have a nucleus in which we have protons and neutrons. We have orbits in which electrons are revolving. Now, think of heavier atoms or heavier metals in which atomic number is 50, 51, 52, and so on till 90, 92, 94, right? We are talking about heavier metals. Okay, then let's do one thing. Start with the simplest one, hydrogen. We know that in structure of hydrogen, the ordinary hydrogen, we have just one proton and we have just one orbit in which electron is revolving. If you provide energy to this electron, it will jump to a higher orbit. If you provide more energy, it will jump to next higher, next higher, next higher. Now, what you will be observing, this is orbit number one, this is orbit number two, orbit number three, orbit number four, and orbit number five. If electron is present in orbit number one, it must be having a definite amount of energy. That amount of energy is called binding energy of the orbit, and it is denoted by A1. A1 means the amount of energy needed to keep the electron in first orbit. If you want this electron to move in second orbit, energy should be E2. If electron wants to jump from any lower orbit to any outer orbit, it will absorb energy. Let's say this is electron. If this electron wants to jump from E1 to E2, it needs energy, and that energy will be E2 minus E1. This amount of energy is known as excitation energy. This amount of energy is known as excitation energy. Let me write here. This is excitation energy. Why are we calling it excitation? Because it will excite the electron from orbit number one to orbit number two. And this E1 and E2, this energy is known as binding energy. This energy is known as binding energy. Now, if electron wants to jump from first orbit to third orbit, what do you think? Will it be needing the same amount of energy like A2 minus E1, or it will be needing different amount of energy?
Different.
Different amount of energy. And that amount of energy will be A3 minus E1. If electron wants to jump from first orbit to, let's say, orbit number 4, it will be needing even more energy. That energy will be E4 minus E1. That's why Max Planck gave idea of quantization. Bohr gave idea of quantization, that when electron is revolving in an orbit, it will neither absorb energy nor lose energy in any random amount. It will absorb energy in a definite amount. It will absorb energy in a definite amount. Why in a definite amount? Just for the sake of understanding, just imagine the energy of first orbit of hydrogen atom is minus 13.2 electron volt. Just imagine. Okay, let me do one thing. Use random value. I mean, if I use actual values, addition and subtraction could be challenging. So let's use easier value. Let's say energy is 8 joule for the first orbit. I'm reminding you again, these are not actual values. 8 joule. For second orbit, it needs to be 14 joule. For third orbit, it is 16. For fourth orbit, it is 18. For fifth orbit, it is 19. So the electron which is in orbit number 1, it needs to absorb a photon that will enable it to live in any one of the outer orbit. For example, if electron has option to absorb one of these photons, let's say there's a photon of 1 joule, 2 joule, 3 joule, 4 joule, 5, 6, 7, and 8 joule. Remember one thing, photon is electron is very particular about what photon it will be absorbing. Why? Electron is in first orbit where energy is 8 joule. If it absorbs one photon whose energy is 1 joule, its energy will become 9 joule. And with 9 joule, electron can neither live in this orbit nor in this orbit. And we know that the space between two orbits is known as forbidden region. Space between two orbits is known as forbidden region. So electron will never absorb 1 joule. Similarly, electron will never absorb 2 joule. Why? If it absorbs 2 joule, its energy will become 10 joule. And with 10 joule, it cannot live anywhere. Are you people getting it? So which of these photons electron can absorb?
8 joules.
I think 6 as well. No? Because if electron absorbs 6 joule, its energy will become 14. It will jump to second orbit. And if it absorbs 8 joule, it will its energy will become 16. It will jump to third orbit. Anas getting it? Okay. That's why I said when it comes to absorption of energy, electron cannot absorb 2 or 3 photons at a time. It is just like Einstein explanation for photoelectric effect, one photon, one electron model. It is exactly the same thing. Electron needs one definite amount of energy. That definite amount of energy, according to Max Planck, is given by E is equal to hf, where E is energy, h is Planck's constant, and f is frequency. So electron will absorb a definite amount of energy that will allow it to jump from any lower orbit to outer orbit. So what we can say, when electron absorbs energy, it jumps from lower to outer orbit. Now do vice versa of it. If electron wants to come back to its original orbit, why electron wants to jump back? Because electron can remain in excited orbit just for 10 power minus 8 seconds. This is the excitation time. The duration for which an electron can remain excited is actually 10 power minus 8 seconds. It is actually a very short period of time, right? Even it is less than 1 microsecond. It is close to 1 nanosecond. Nanosecond is 10 power minus 9. So electron, if jumps from any inner orbit to outer orbit, it will absorb energy. But in any excited state, it won't remain for a longer period of time. So when it comes back, it will emit the absorbed energy and come back to its original orbit. That's why substances glow when you heat them. For example, if you take an iron rod and you put it on the flame for 2 minutes, quite possible the rod is not glowing. But if you bring that rod close to your palm or close to your face, you will sense that rod is emitting some radiation. Those radiations are actually infrared. Those are not visible. You cannot see them. It means that electrons are jumping from outer orbit to inner orbit in a manner. The wavelength they are emitting is infrared radiation. You cannot see them, but you can sense them. Is it clear? If you keep on heating them, what will happen? Electron will absorb more energy. It will jump to even more distant orbit. So when it come back to the first orbit, it will be emitting more energy. That more energy could be in visible region. So it starts with red color, because I hope you remember, in visible light, violet, indigo, blue, green, yellow, orange, red. Red is the minimum frequency. So when you are heating something, it turns red. After some time, you will see some sense of orange and yellow in that flame as well. How many of you have observed something like it? When you heat something, it turns red first, then you will see some shade of orange or yellow in it, but red will remain predominant. Why? Red will remain predominant because it depends upon which color photon is in larger quantity. For example, if something is emitting 1 million photons for red color and just few thousands for orange, red is predominant. You can only see red color. But if we have 1 million for red, we have, let's say, 0.5 million for orange. So you will see some shade of orange as well. And a point is reached that body will be glowing with white color. When something is glowing with white color, what does it mean? That object is emitting actually all colors. That object is emitting photon of each color in comparable ratio. That's why that object actually appear as white color. How many of you are actually able to understand what I'm trying to say? Okay, Anas is getting it. Yes, Alan, Amna, Maham. So we should know one thing. How electron jump from lower to outer orbit, and what happened when electron jumps back to its ground state. Ground state means it will jump from any outer orbit to any inner orbit. So it will be emitting certain definite amount of energy. It will be emitting a definite amount of energy. Now, this energy could be infrared, this energy could be visible, this energy could be ultraviolet. It depends that how this energy is generated. What does it mean? Electron jumps from which orbit to which orbit? Electron jumps from which orbit to which orbit? For example, if you take lighter atom like hydrogen, in which we have only one electron, so obviously we are not dealing with very large amount of energy. But if you consider a heavy metal, in heavy metal, we will be having so many protons, we will be having so many electrons. So energy of each orbit will be very large. Energy of each orbit will be very large. For example, if in a lighter atom, electron jump from, say, second orbit to first orbit, it jump, it will emit a photon. Quite possible that photon is infrared. But if you think of heavy metals, in which we will be having so many protons. So many proton mean a strong field. In a stronger field, you will be having more electric potential energy. If electron jump from any outer orbit, let's say n equal 5 to n equal 1, so what do you think? It will be emitting infrared radiation, or it will be emitting enormous amount of energy in
Enormous
comparison to the
amount.
first example? Enormous amount of energy. And this energy could belong to a spectrum where wavelength is around 10 power minus 10 meter or 10 power minus 9 meter. And this wavelength actually corresponds to wavelength of X-rays. So actually today, what we will be discussing is X-ray. Actually, we will be discussing medical imaging today, and hopefully I will be able to complete at least topic of X-rays in today's class. And once we are done with X-ray, I have to teach one topic from the old chapter that was related to spectrum and all. But once we are done with it, all that stuff will become very easy for you. Now, up till now, what I tried to explain. When electron jumps from inner to outer, it absorbs energy. When electron jumps from any outer to inner, it loses energy. Second thing, if you look at the orbit in the first diagram, you will see one difference. Here, distance is this, distance is this, distance is this, distance is this. What does it mean? As the orbit number is increasing, the distance between two consecutive orbits is actually decreasing. They are coming close to each other. If I draw these orbits as level of energy, so let's say this is energy of first level, n equal 1. This is energy of second level, n equal 2. This is energy level of third. I can call it n equal 3. This is energy of fourth, n equal 4. This is energy of fifth orbit. You can call it n equal 5. And we can have another orbit. Just to clear thing what I'm trying to say. Okay, now you will surely agree one thing. The difference of energy between 1 and 2 is large, but between 2 and 3 is smaller than between 1 and 2, but more than between 3 and 4. As the orbit number is increasing, the difference of energy is decreasing. If an electron jumps from this orbit to this orbit, it will generate a very large amount of energy. But if electron jump from this orbit to this orbit, it will generate very less amount of energy. Do you agree? So we can say if electron jump from outermost orbit to the innermost orbit, then the probability of getting very high energy photon is possible. Very high energy photon means very high frequency, because E is equal to hf. And very high frequency means very small wavelength. And very small wavelength means that could be X-ray region. That could be X-ray region. That's why to produce X-rays, we just don't need transition of electron. We need transition of electron from outermost orbit to innermost orbit, so that we can make sure the wavelength emitting is of the order of 10 power minus 9 or 10 power minus 10, so that you can call it X-ray. Otherwise, quite possible, the wavelength is of order of 10 power minus 7, which is actually visible light. So if we need even shorter wavelength, we need to make sure electron is jumping from outermost orbit to innermost orbit. How many of you are getting it till here? That for generation of X-ray, electron should jump from outermost to innermost. Now, what problem we will be facing? Let's say we talk about a metal whose structure is like this. Remember, in first orbit, we can have 2 electrons. In second orbit, we can have 8. Okay, let me just write the number. Then we can have 18 electron. And then let's say in any outer orbit, there's an electron. We want this electron to jump to the inner orbit. What do you think? Can this electron jump to first orbit, or it cannot? Yes. If electron wants to jump in this configuration, if electron wants to jump to the first orbit, is it possible for the electron, or it is not possible?
Not possible.
Why?
Sir, electrons will repel each other.
Okay, electron repel each other, but there is another logic. In first orbit, we can have only 2 electrons. In first orbit, we can have only 2 electrons. In second orbit, we can have only 8 electrons. So in first electron, 2 electrons are already present. In second orbit, 8 electrons are already present. So there is no room for any other electron. It's just like if in your bicycle, we can have only 2 wheels. You cannot accommodate the third one. But let's say you have a wheel and you have a wish that this wheel should fit in your bicycle. What you need to do? You need to remove one of the wheels of your bicycle. Are you thinking the way I'm thinking? For the X-ray production, you want this electron to jump from outermost orbit to innermost orbit. But the problem is innermost orbit is filled. There is no space for any other electron. And if you want this electron to jump from outermost to innermost, it means that first you need to make a cavity in the first orbit. You need to make a cavity in the first orbit. In the production of X-ray, making this cavity is the toughest thing to do. Making this cavity is the toughest thing to do. And how do we do this? I will be explaining, but why we are doing it? Once we have a cavity in first orbit, let's say, we created the cavity. What will happen? Electron will jump and now it can fill this cavity. When it fills this cavity, it will generate a very large amount of energy which may belong to X-ray region, which may belong to X-ray region. So if anyone asks you what is the principle of production of X-ray, X-rays are generated when electron jumps from outermost orbit to innermost orbit. But electron cannot jump to innermost orbit because innermost orbit is always filled. So first you need to make cavity. How do we make this cavity? Now, this is something that I will try to explain. Just listen very carefully. I think many of you will be able to understand this thing very easily. What we do, we take a tube. Okay, it is not necessary that this tube is of this shape. You may use any shape for this tube. This is a tube. This tube is actually coated with material that is actually very strong and it won't let any radiation go out of it. So this is the coating. This is the coating. We need to produce electron. We need to produce electron. So how we will produce those electron? Electrons are produced by thermionic emission. Now this word should remind you of J.J. Thomson experiment. We have discussed J.J. Thomson experiment. Quite possible many of you remember how to produce electron by thermionic emission. We will take a filament. We will take a filament. That filament is connected to a voltage source. That filament is connected to a voltage source. So what actually happened? When current passes through this filament, the filament will heat up. Heat up means atom will start to ionize, it will start producing electrons, right? Those electrons will generate in random direction. Those electrons will generate in random direction. What we do, we use a metal plate. That metal plate is usually of some heavy metal. This metal plate is usually of some heavy metal, something like this. And you may see this metal plate is actually not straight. I have make it little slanted. It's just like If you are making salad and you want to cut cucumber, right? So there are a number of ways to cut it, because cucumber appears something like this. If you are taking cross section like this, it will appear circular in shape. It will appear circular in shape. But if you are cutting it slanted, it will appear elliptical in shape. What difference you will observe? More surface area when you cut it slanted way. How many of you are actually getting it? So we want to expose more of the metal. We want to expose more of the metal. So this metal surface is little slanted. We will connect a wire here, and this other wire is connected to this point, and we will be applying a very high voltage here. That voltage is usually from 50 to 200 kilovolt. Kilovolt means 50,000 volt to 200,000 volt. Now you can imagine how large this value is. This voltage is accelerating voltage. Remember this equation. Kinetic energy is given by Q times V, or in easier word, energy is given by Q times V. The more potential difference means you are accelerating the electron more and more. So what will happen? The electrons which were traveling in random direction, now they all will be accelerated towards the metal target. They will be moving in these lines to hit the metal. Something like this. These are electrons which are moving towards metal. When electron hits the metal, what actually happened inside the metal? A cavity is formed. How? Just imagine this is the orbit, innermost orbit, in which electron is revolving. You have fired billions of electrons on this atom. You have fired billions of electrons on this atom. Out of those electrons, one electron will successfully hit this electron and remove it from the orbit. One electron will successfully hit this electron and remove this electron out of the orbit. So we will be having a cavity here. So what do you think? Is it a definite thing to happen, or it is working on probability only?
Probability, sir.
Probability. Remember one thing, production of X-ray works on probability. It's not like that if you fire 10,000 electron, they will generate 10,000 cavity. Quite possible. 10,000 electron can produce only one desired cavity. Why? Because you cannot see inside the atom. So quite possible the electron made cavity in this orbit. So if electron is making cavity in this orbit and electron jumps from here to here, quite possible this is just infrared or visible light. It is not X-ray region. X-ray is possible when electron will jump from outermost to innermost. That's why I said production of X-ray works on probability. When you are firing so many electrons which are very energetic on this plate, which is connected to positive terminal, if you are taking chemistry, you will agree. This plate is anode. So this will become cathode. This will become cathode. This anode, with this anode, we do two things. When so many electrons which have so much energy, I mean 50,000 volt to 2,000 volt accelerating voltage is a very large value. I mean, if you remember this equation, kinetic energy is Q delta V, or E is equals to QV. Charge of electron is 1.6 exponent minus 19. If I'm using 2000 volt, just simplify this thing. Just simplify this thing. We will be getting something around, if I'm not wrong, 3.2 exponent minus 14. If any one of you can verify, I'll just multiply it manually. I think it is fine. 2 into 1.6 is 3.2. And minus 19 plus 5 is minus 14. Did any one of you check it? Now, if we are getting this value, you can convert this value into electron volt, because normally energy is measured in electron volts. So how to convert energy in electron volts? 3.2 exponent minus 14 divided by 1.6 exponent minus 19. You will surely be getting this answer. Because in ping working, I multiplied by 1.6. Now I will be dividing by 1.6. So I will surely get 200,000 electron volt. What it means, this is an enormous amount of energy. So just imagine when millions of electrons with this much energy hitting the anode, you have increased the cross section of anode as well, so that we have more encounters. The temperature of anode will be rising significantly. So there are two approaches. In some cases, we will be circulating water around it to keep it cool. We will be circulating water around it or around this tube to keep it cool. Or sometimes these anodes are designed like this. They will be fixed on some axle, and this axle is connected to some rotation mechanism. Now just visualize it like a fan. If you are sitting in front of fan, you can see the three blades which are constantly spinning. This anode keeps on spinning like this, so that you can maintain the temperature at certain level, so that the temperature shouldn't exceed to an extent where it can damage your arrangement. So up till now, what I tried to explain, how X-rays are produced. X-rays are produced by creating cavity in a heavy metal, right? That heavy metal could be molybdenum or tungsten or something like it. When millions of electrons are bombarded or fired on that, the temperature will rise. So either we will be using water as a coolant, or we will be spinning the anode to maintain its temperature. It is working on probability. It is not necessary if you fire 10,000 electrons, so you will be having 10,000 cavity. Quite possible you have only one cavity. Quite possible that you will be having only one cavity. So what we usually do, we just work on a certain ratio, that if we are using these many electrons, we can have only one cavity, so that we have tentative number or amount of X-ray that can be produced. Now, these electrons will generate cavity. Once cavities are generated, outermost electron will jump into the innermost electron, and X-ray is generated. X-ray photon is generated. Now, when X-ray photon generates, once again, they will be generating in random direction. They can be generating here as well. But remember, this gray shield is the protection. No radiation can come out of this setup. We make a narrow window or narrow opening in this setup. How? In a certain part of this. This shield is thinner. This shield is thinner. So what is advantage of it? Advantage of this setup is these photons will come out of it, but other photons will remain inside the tube. That's how X-rays are generated or produced. I didn't explain anything related to X-ray yet. We have to discuss so many concepts, but currently or up till now, I just tried to explain you how X-rays are generated. By the way, how many of you are actually able to understand what did I say? Okay, Anas is getting it, Maham getting it. Yes, Alan, Amna. Are you people able to understand? Okay. Now, once X-rays are generated, we will obtain their spectrum. And what we have observed. Now from here we will discuss so many things related to X-ray. So listen very carefully. On y-axis, we will talk about intensity. I hope you remember what is intensity. Intensity is energy per unit area per unit time. Since energy over time is power, so intensity is power over cross-sectional area. On y-axis, we have intensity. On x-axis, we have energy of X-ray photons. When we obtain the spectrum for certain metal at certain potential difference, because we have applied a potential difference 50 to 200 kilovolt to accelerate the electron, we will obtaining different curve. Let me draw the curve first, then I will explain what this curve is actually showing. This curve will acquire some shape like this. This curve will acquire some shape like this. Now, in this curve, there are two things. One is this part, and you can see a peak at some point. What it represents. Now, just imagine this is the electron which you have fired. So, this is the electron which is bombarded on the anode, and this is the anode. Let me draw it. Let's say this is the anode. This electron kept on traveling because you remember from Rutherford atomic model, majority of the spaces of an atom are empty. Quite possible, this electron keeps on traveling within it till it collides with the electron. Till it collides with the electron, and there is an atom like this. And there must be some outer orbits. So from this point to striking this electron, what do you think? Can I say the electronic scene in this metal will keep on opposing the electron? Are you able to understand this statement? When electron is traveling outside the metal, it keeps on traveling freely. Once it enters the metal, in the metal we have electronic scene. There are so many electrons. Electrons repel each other. Because of that, this electron keeps on decelerating. And when electron decelerate, it will be losing energy. This continuous curve actually represent that amount of energy which is generated because of deceleration of electron, which is generated because of deceleration of electron, and this is known as, okay, let me do one thing, highlight it. This is known as breaking radiation. This is known as breaking radiation. Why breaking radiation? Because from here to here, electron is decelerating. Why electron is decelerating? Because other electrons will be repelling it. Because other electron will be repelling it. Since electron is decelerating, so it will be losing energy. That energy will appear in the form of that curve. So these are known as breaking radiation. You can relate these yellow shading together. How many of you are actually getting it? By the way, If I'm not wrong, X-rays were discovered by Roentgen, and quite possibly he was German. This breaking radiation is actually English translation of a word which is known as Bremsstrahlung. Bremsstrahlung is a German word which actually means breaking radiation, which is known as breaking radiation. So, when we obtain energy graph or intensity graph for X-rays, we obtain two things. One is a smooth curve, just like normal distribution, that actually represents breaking radiation, and there is a peak. Once we have created a cavity, an electron from outermost orbit will jump to innermost orbit to fill this cavity. So the amount of energy it will be generating is actually of characteristic X-ray, which is indicated by this peak. This peak actually corresponds to this amount of energy. This peak is actually known as characteristic radiation. This is known as characteristic radiation. So in a graph of intensity for X-rays, there are two parts. One represents breaking radiation, other represents characteristic radiation. Since in a heavy metal, cavity can be created either in first shell. Quite possible many of you remember that first shell is known as K. Next is L. Next is M. Do we remember this thing? First is known as K shell, then we have L, then we have M, then we have N. How many of you know this from chemistry? Because the thing I'm going to explain is not part of your syllabus, but it is good if you know. It will clear your concept actually. If a cavity is created here, so electron may jump from here, electron may jump from here. This series is actually known as K series of X-rays. If a cavity is created here, so electron will jump from here. The series is known as L series. So in X-rays, we can have different type of series. It depends cavity is created in which orbit. Obviously, the more energetic is the one which is in K series. And even in K series, which X-ray will be more energetic? The one which is generated because of transition from L to K or transition from M to K. Obviously from M to K. Because the more the distance between two orbits, the more will be the emission of energy. That's why these graphs may take multiple peaks as well. Multiple peaks means you will see two spikes. Why two spikes? Because quite possible it is generating one line of K series, one of L. Quite possible it is generating two lines of K series. So it means that we can have multiple characteristic as well. So it is not necessary that in one spectrum we have only one peak. We can have sometime 3 or 4 peaks as well, because we can have different cavities and different electrons from different orbit can jump to fill that cavity. So this is all about production of X-rays. Now the question arises how X-ray is helpful. X-ray has a certain unique characteristic. And what is that characteristic? It can pass through human flesh, tissues, skin, but it cannot pass through bones. And when X-rays strike a photographic plate, it actually darkens the photographic plate. It actually darkens the photographic plate because many students actually feel that when X-ray will hit the photographic plate, it will make it bright. No. When X-ray hit photographic plate, it actually darkens it. That's why, let's say, when doctor take X-ray of a fractured bone, what will happen? Let's say bone is something like this. Okay, this is just an illustration. Let's say there is a bone. Ideally, this bone should be solid. So when I will be obtaining the X-ray, what will happen? Light X-ray won't be able to reach the photographic film where in the region of bone. So X-ray will expose all other region around the bone. This one, this all region will get darkened. This all region will get darkened. That's why in X-ray, bones appear white and other region appear black. How many of you have noticed this thing? Okay, Anas has observed this. So just imagine we have a bone. In front of bone, we have X-ray machine which will be emitting X-rays. Behind the bone, we have photographic film. So what will happen? X-ray cannot pass through the bone. So behind the screen, all the photographic film will get black except the region where we have bone. But what if we have a fracture in this bone? What if we have a fracture in this bone? So this bone will be something like this. What we will be able to see, the light will be able to pass through this gap and reach the photographic film. So doctor can see there's some fracture. That's why X-rays were able to penetrate. How many of you actually able to visualize what I'm trying to say? Okay, that's good if you people are getting it. Now, these X-rays have many characteristics. One of those characteristics is basically hardness. What does hardness represent? Hardness represents the penetration power of X-ray. Penetration power of X-ray. And if you use your common sense, you will surely agree it can easily be altered by changing the potential difference between filament and target metal or material. This one, I'm talking about this voltage. This one. If you increase this voltage, it means that you are giving more and more energy to the electron. And more energy to the electron means you are dealing with high energies. So the X-rays which are generated will be having very large amount of energy. So their penetration power will be very large. Right? So when we talk about hardness actually represent penetration power of X-ray that can be altered by using more potential difference between filament and the target material. Number one, if X-rays are not hard, then X-rays will be soft. No. What does soft X-ray mean? If penetration power is less, it means that absorption power is more. If penetration power is less, it means that absorption power is more. If X-rays have very less hardness, it means that X-rays are soft. Soft means their penetration is less. Penetration is less. Therefore, their absorption is more. And like all other radiations, if radiations are being absorbed in the body, they will cause some ill effect or some hazards in the body. Some hazards in the body. It means that when X-rays are generated from this tube, these X-rays must be containing both kind of X-rays. They must be having hard X-rays, they must be having soft X-rays. What we need to do? We need to get rid of soft X-rays. Otherwise, these soft X-rays won't help in getting the image, but they will cause complications. They will cause health hazard in the patient body. So we want to get rid of them. So what we usually do, When X-rays are coming out of this narrow window, for example, the window I draw, let me draw just slightly. I'm taking care of color so that you can relate it afterwards. When radiations are coming from this, let me draw a few dotted as well. Let's say dotted means soft X-ray. Dotted means soft. Continuous mean hard X-ray. What we do? We put some aluminum plates in front of them. We put some aluminum plates in front of them. What this aluminum do? This aluminum plate will absorb the soft X-ray, and what managed to come out of it is just hard X-ray. Are you getting it? Because you should know everything. Because when you go for X-ray, the radiologist actually decides the dose, what amount of X-ray is needed for your body. And that amount of X-ray must be containing both things, hard and soft. So he should have understanding how to get rid of those soft X-rays, because they will be in your dose and they won't be doing anything except producing some health hazard or some negative impact, right? So we should know what is hardness and what is softness. Now, when X-rays are traveling inside patient body or inside anything, they suffer decrease in power. They suffer decrease in power. This decrease in power is known as attenuation. Now, this terminology we will surely be using in communication as well. What is attenuation? The gradual decrease in intensity. Because we are talking about X-rays, so let me call it of X-rays. Otherwise, in general, attenuation means the gradual decrease in intensity. The gradual decrease in intensity. So we have a formula. That formula is something like this. Remaining intensity is I naught times e raised to minus mu times x. Are you able to recall this composition of formula? I guess in nuclear physics, I did mention few equations like this, and I told you this anything which is changing exponentially, anything which is decaying exponentially, we use this standard equation for that. So I is the intensity which is left, I naught is the original intensity. In case of X-ray, you can say I naught is the incident intensity and I is the transmitted intensity. Okay, let me write everything. Once I will be done with this explanation, you will surely be able to understand. I naught means incident intensity. I mean transmitted intensity. This mu is a constant. This mu is a constant and it is known as coefficient of absorption. This is a constant and this is known as coefficient of absorption. Number one. Number two, what is this x? This x is actually the thickness. This x is actually the thickness. Now, what I'm trying to say, let me draw a graph, you will surely get it. On y-axis, we have intensity.
Sir, your mic is malfunctioning today.
My mic is not functioning today. What does it mean?
Sir, sometimes your voice is very low.
Okay, just give me a second. Let me cross check. Anas, is it getting better now?
Yes, sir, it's fine now.
You should have told me. I'm continuously speaking for the past, you can say 55 minutes. And when we have just 24 minutes, you are saying my mic is not working.
Sir, it got worse gradually.
Okay. So on y-axis, we have intensity, and x is actually the thickness, which is on x-axis, right? Let's say this dotted line represents air, because every one of us must have gone through the process of X-rays. Not for medical purpose, at least for your MH ID. Every one of you must have gone through this thing. So what they do, you will be standing here. There must be a photographic film. There must be X-ray gun, and there is the radiologist. So when he transmit the X-rays, X-rays are traveling in air. So when X-rays are traveling in air, their intensity will remain the same. Their intensity will remain the same. Now let's say this is human body. This is human body, right? And in human body, we have flesh and we have bones. Now see the difference. Since X-rays can pass through flesh, what you will observe? The intensity will decrease. The intensity will decrease, but it will decrease by very less amount, because more penetration means less absorption. But if we are talking about bones, what will happen? This intensity will drop, because it cannot pass through the bones. Are you people getting this graph?
Yes.
Okay, just a minute, because a student of some other class is trying to join this class. Let me inform them first. Okay, so if we are talking about absorption, you can see in flesh, intensity will drop a little. In bones, it will drop by a large amount. Similarly, the way in nuclear physics, we used to have half life. We used to have a quantity which is known as half life. Here we have a thickness which is known as half thickness or half distance. What is half thickness or half distance? Half thickness or half distance is the distance in which intensity reduces to half of its original value. In which the intensity reduces to half of its original value. And formula is almost exactly the same. Ln of 2 divided by mu. Half thickness is given by ln of 2 divided by mu. Why? I hope you remember, I did this calculation in the class as well while solving past paper. This equation is exactly the same. Just replace x by half of x. So I will be replaced by I naught over 2. Just simplify it. You will surely end up with the formula that half thickness is given by ln of 2 divided by absorption coefficient of the material. Is it clear till here? Okay. So up till now, we have discussed everything, how X-rays are produced, how to separate hard and soft X-rays, what is attenuation, what is the mathematics of attenuation. Now let's talk about quality of X-ray that you will be obtaining. And that quality is defined by two characteristics. One is known as sharpness, and other is known as contrast. These are last two things that we will be discussing in context of X-ray. And I think it will be more than enough for you to attempt any questions related to this topic. One is sharpness, one is contrast. Now, what is sharpness? I mean, sharpness is something
Sir, we can't hear you.
Okay, can you hear me?
Yes, sir.
Okay. So what I was saying, in order to obtain sharp image, we need to use narrow beam of X-ray. Why narrow beam of X-ray? I was explaining this thing before getting disconnected actually. When we use a narrow beam on the screen, you will obtain a very sharp image on the screen, right? This is known as
Umbra. Umbra actually means shadow, right? Umbra actually means shadow. When we are using a narrow beam, what actually happened? We have a region above it which is known as penumbra, above and below the shadow. It means partial shadow. And it means full shadow. Now, the region of partial shadow is very small in case of small source. If you use a wider source for the production of X-ray, the length that you are using is actually very large. For example, you are using source like this. So what actually happened? The region of this penumbra is actually very wide. And when it is very wide, it means that sharpness of the X-ray will affect. So one way of increasing the sharpness is narrow beam of X-ray. Second thing is aperture. What is aperture? Aperture is the opening through which X-rays are coming out. Aperture is the opening through which X-rays are coming out. So second way of improving the sharpness is use of aperture. When these rays are coming out of this tube, let me show from here. I'm talking about this plate. Number one, what we do, we put aluminum plates to absorb soft X-rays. After that, what we do, we use 4 plates in this format. 1, 2, 3, and 4. And actually the affected opening is this region. We can control these plates. We can move them up and down. We can move them up and down. We can move them left and right. To adjust the size of this opening. This opening is actually known as aperture. By using this aperture, you can adjust the size of X-ray beam that is actually coming out. You can use the size of X-ray beam that is actually coming out. One last technique by which you can change the sharpness. How much region of this anode you are using? Just imagine when X-rays are generated, they will be hitting anode. So this is the anode. If you are using a very wide region of anode, so one X-ray will come from here, one will come from here, so it will behave like a wide source, right? So we try to use a very targeted region of the anode. If you are using a very targeted region of anode, for example, I do use just this portion of the anode, the X-rays will be coming, will be very focused. Are you able to understand this point? So we should be using targeted portion of an anode. Now, the last thing is basically contrast. What is contrast? The difference in degree of blackening between the structures, right? Because radiation can pass through X-ray, can pass through flesh. They can pass through a sac inside the body which is filled with certain fluid. So every material will be having a different level of attenuation. So if all are showing by same gray color or black color on the screen, you won't be able to distinguish. So contrast means the difference between the level of blackening, with the help of which you can say it didn't absorb anything, it absorbed 80%, it absorbed 60%, it absorbed 50%, so that you can distinguish different organs or different parts of the body. So this is all about X-rays that we should be knowing. So in next class, what I will be doing, we will be solving questions of X-rays first, because now topic is medical imaging, but I first solve questions related to X-rays so that the concept remain in your mind. And hopefully in next class, we will solve 2 to 3 questions on X-rays, and the next topic that I will be teaching will be CT scan. But this is the only lengthy topic you can say for medical imaging. CT scan is very short topic, MRI is very short topic, ultrasound is actually very short topic. X-ray was, you can say, very lengthy topic actually, and I tried to cover all the aspect of the topic. If anything is left, when we will be solving questions from past paper, we will surely be discussing. If you have any doubt, any question related to it, you may ask. Otherwise, we will resume from here in next class. By the way, how many of you were able to understand at least 70-80% of whatever I have explained? Because 70-80% is even fine with me. Because when we will be solving questions from past paper, things will surely get better. Okay, so we will resume from here in next class now.